ratio factor depends on the wind speed and air temperature. Following data represents the wind speed. So we got the wind, miles per hour, and then we got the factor. The wind is 5, 10, 15, 20, 25, and 30, 25. The factor is 12 minus 3 minus 11 minus 17 minus 22 minus 25 and minus 27. So your question was, do you want to do the whole thing, or do you want, what was your question? I just want to find the slope, y-intercept, or regression line. Okay? Now, in order to do that, what should we really do first? We should figure out if regression is even appropriate, right? Because just looking at data, I mean, I don't know about you, but I can't just go, oh, that's a straight line, that's a curve. You know. How did you figure that out? Scatter plot, right? So, let's do a scatter plot, right? Insert. Good thing I think on it, but you can ace the test tomorrow, or Thursday, I guess. What is it? How about right here, this one here? Scatter plot, hey, how about that? Let's take the first one. Hopefully your computer's not as stupid as mine. Okay, so what do you think?
Yeah.
It's a little curvy, right? Makes you a little nervous, but we can check and see if, so a straight line looks reasonable. It might be a little bit curvy, so maybe it won't be good, but we'll do what you asked the first time, and then we'll decide. This is a good question. How did I pick such a good question? Okay, and then we'll just look at our residuals, which is not what you asked, but that's a good question, and see if really regression is good, and we should do something else. Okay? So, we're going to assume from now that straight line's okay. It's definitely not parabolic or something. Okay? Oh, it's you. It's ventriloquist. Okay? So find the R value. We should do that by hand, right?
Yes.
I should put this one on testing set. Should I do that? Give you guys a good test?
If you have problems, you're in here.
What's that?
If you have problems.
I can give you. Should I do? I could change my mind really quick. Do you guys want to do that? Testing center.
No.
It
No.
says testing center.
No. Nobody.
There were some people. I thought there was one. Everybody else wants to do it in class? Who wants to do it in class? All right. So what?
Find your averages.
So we'll do the cheater method, correlation. Okay? But you should know how to do this by hand, comma, this, right? Since that's what Ryan asked, we'll just go for what he asked. So what do you think about that correlation?
So can we use the cheater method, or do we have to do it?
Tomorrow, Thursday, you're gonna have to do at least one by hand. Okay?
It's okay. Just that's okay.
What's okay? So is it strong, weak, or moderate? We would say it's strong correlation, okay? Okay? Now, according to my formulas, how do I find my slope?
R times your standard
M
deviation.
equals R times
Standard deviation of y.
standard deviation of y divided by standard deviation of x. Okay, so I find my R. I also need to find my standard deviations, right? I won't make you do that one by hand. correlation will be good enough. Okay? Okay, so my slope m equals my correlation coefficient times my standard deviation of y, which is my windshield factor, divided by my standard deviation of x. Okay? So I got a slope of negative 1.22. Is it okay that it's negative?
Yes.
Should be negative, right? Okay, in this case. Now my v equals, what's that formula? You guys can look it up.
I bar minus B1 times
Minus y bar minus m times x bar. Okay, so I need my y bars and my x bars, which are, what are they, what's another word for x bar? Means. The means equals the mean. Gotta fix that command bill. The mean of each of these. Okay. So B is going to equal in this case y bar minus m, which we found up here, times x bar. Okay? So now that I've found my m and my b, what is my regression equation, Ryan?
One second, I'm still filling out the.
Sorry.
That doesn't look right.
So my regression equation is,
So, are you trying for up above, with the y bar minus, is that, for that, is m the slope?
M
So
is
it's
your
the
slope.
slope times x bar?
yeah. Now, by the way, that's not exactly the same thing that you have in here. Let's look at your formula sheet that you're gonna see tomorrow. It doesn't use m and b, it uses what? Right here,
Oh, yeah, B sub 0.
okay? B sub 0 and B sub 1, are you gonna be able to, know that?
Yeah.
That's your information that you want right there. Okay?
B sub
So,
1 is your slope.
this is what I'm calling B, sorry, this is what I'm calling M, which is B1. Okay? So, what should your equation be, Ryan?
So the y equals the negative 1.22 x plus 11.2857.
Okay, and how can we check your answer?
Right click ground.
Pick a point, any point, right click, add trend line,
Display.
and put the equation and the r squared. Oh, we never figured out our r squared, we should have done that. Okay? Can we find the r squared based on stuff we've already calculated? R squared is simply correlation squared. How about that? Does that make you feel smart? SMRT, smart, smart, smart.
How do you find the correlation by hand?
You're gonna need to. I didn't do it today, but we can do. Do you wanna do it?
Yeah.
Let's do it.
Can we do,
Box whisk from Excel.
no, to see if that's really okay.
What's okay? Oh, we need to do residuals
Yeah,
too.
residuals.
What do you guys wanna do, residuals or correlation coefficient by hand? Both of them got 10 minutes. What do you wanna do first?
Do both fast.
Go fast? I can go fast.
Just crank, and we'll
Go.
just like see what we can catch.
Here, we'll do the correlation coefficient first. Okay, correlation coefficient. Remember what the equation was?
You gotta find your means and
It's right there. Okay? So basically, I'm gonna need my z-star, z for my wind, I'm gonna need my z for my factor. And in order to find my z-score, I'm gonna need my mean and my standard deviation, which actually I already have found. Okay, so my z-score for my wind is gonna be the data minus the mean, F4, divided by the standard deviation, F4, right? We're going fast? Is that slow? Is that fast slow enough?
I'll send you guys the video. We'll go quick.
You got the video.
Yep.
Okay, you gonna post the video on YouTube?
No.
For the whole class?
Well, I mean, if you don't mind, but
Should I do that? Should we post the video?
make a channel
If
for
you
you.
wanna post it,
Yeah, I'll post it.
I'll post it in my other class too.
Okay.
Okay, can you hear?
Oh, yeah.
You can?
Yeah.
Okay, cause I'm nice and loud.
Mm-hmm.
All right, so your factor is gonna be your data minus your mean, F4, divided by your standard deviation. Okay? Did I not upload that one? Oh, I forgot to upload that one. Which you know when you see the division by zeros, right? So good. Okay, fix that one. Then we're gonna get our product here, okay? We're gonna multiply those two z-scores together. And you're gonna copy that down. And then you're gonna get your sum, and you're gonna add that up. And hopefully, by the way, there's our answer right there. That's the answer we're looking for. And now we're gonna divide by what? N minus one, right? What's my n? Is my n 7 or 14? It's 7, it's the number of pairs. So I'm gonna divided by 6. Okay? Am I gonna get negative 0.95215? I am smart. I'm as smart as Excel. Okay? Got it. And if I square that, I can get my r squared. Okay, now we're gonna do our residuals. So we're gonna find that, because that looks a little bit curvy, right? So there might be a better method than linear regression. Of course, even if there is, we're not gonna teach it to you, but we're gonna tell you that there is a better method. Okay, so how do I do my residuals? And by the way, you're properly labeling that graph, unlike me, right?
Yes.
Because we're in a hurry. Look, it only took me 5 minutes to do that regression, or the correlation. I'm talking even, but you guys can't do it or anything. Okay, residuals, how do I find it?
Actual minus predicted.
The actual minus the predicted. Okay, residual equals the actual minus the predicted, which means I need to find out the predicted, right? So predicted, now we do the actual minus the predicted, okay? So how do I predict what it should have been? Because look, we're way off the line. That's our residual right there. And we would have only predicted probably 5, and we got 12, right? Okay, so how do I do that?
You plug x into your equation.
Gotta plug it into this equation that I just found here, okay? So I'm gonna take my slope, okay, and I'm gonna F4 that because I always wanna use my slope, times my x. What's my x?
17.
It's 5 in this case. And I'm going to add my y-intercept. I'm gonna F4 that because I don't want that changing. Okay? And then I'm gonna copy that down. Okay? Then I'm going to do my actual, sorry, that's my actual 12. I'm gonna subtract off my predicted. 12 minus 5 is about 7, 6.85. I'm gonna copy that down. Okay? Now the question is, am I doing a residuals or the residuals squared? And what do you need to do? Well, that's actually two questions, isn't it? You should figure out your residuals squared, right? Okay, so we're gonna take this and we're going to square it. Okay? And then we're gonna find our sum. And our sum is 108. What is special about that number? It's what you want to score on the test, right? What's special about 108? Give him a lot of blank stares. Chris knows. No?
Isn't it the higher that number is, the worse your line fits your data? Is that number?
Kind of, yeah. It's actually the smallest number you can get.
Yeah.
So that's a good number, 108 is a good number. If you pick any other line, it's gonna be higher than that. Okay? So now, what am I supposed to graph? Bueller?
Didn't you wanna do like a scatter plot?
Do a scatter plot of,
The residual square.
no,
Or the residual.
the residuals. We don't do the residual squared, only the residuals. So I'm gonna take my wind, I'm gonna hold my control key down, and then I'm gonna do my residuals, which is actually this column here, the action minus predicted. That's my residual column. Okay? So, in this case, I'm gonna do my scatter plot. What do you think about that? Oh, gosh, I couldn't have picked a better one.
It's bad.
Huh?
It's bad.
It's bad. Why is that a bad plot?
Because you
Because
have
we got definitely a curve going. Oh, that's a parabola, right? Okay. So what does that mean in statistical terms?
It doesn't have some big, long definition. I can't remember what
It means something you can't remember.
Well, I know it doesn't have something that you
Okay,
need
it doesn't
for it.
have constant variance. Okay, on this plot we want a null plot. Okay, we do not see a null plot, so therefore is linear regression a good idea or a bad idea?
Bad idea.
A bad idea, so I should not take linear regression. And going back to here, that is kind of curvy there, right? So what would be a better type of regression? You can actually go in here, I think if you click on your trend line, you can say, well, how about if I did logarithmic? Ooh, that looks really good. Polynomial. Oh, by the way, that's 0.998. Polynomial. Now, here, let me give it up. Let me slide this over here. Okay, so look at my R squared. My R squared is even better, and it looks like it fits it almost perfectly. If I click back on the line, I can do a polynomial, which is also 0.99. That one fits pretty good too. We don't want to do moving, so exponential the other one. Okay, so it just means you should probably pick either logarithmic or polynomial. Which one would be better? If you really wanted to get into it, you could do the residuals again, see which one's better, or you could say, you know what? I don't like the logarithms, I'm going to do a polynomial, that's good enough for me. Or I like logarithms because I like them, so that's good enough.
So doing the residuals is just showing whether like the linear.
Yeah, the main purpose is to show that the linear is actually a bad idea, even though it seems like it fits pretty well. Your R squared is really pretty good. Okay, but really, it doesn't. It's too curvy, and you probably should pick a different method.
So it's still with the correlation, it's just not like representing the linear.
Yeah, it just says basically one of these others would be a better option. Okay, but we're mainly concerned is linear good or not, and so in this case we'd say not.
What are the sections that I'm using?
So the sections are 3.5 to 6.2.
I got what the predicted is, but where do you get the actual, what that is now? first time.
So. I'll put it out on Canvas, the discussion board, with like a link to the website. You bet.
Yeah, I couldn't follow along at all.
Yeah.